All right, you guys, we are ready for wind belts and boundaries. Now, this is a lot easier than it seems. Remember, it's always symmetrical about the equator, and I'll show you how I kind of check myself. Now, once again, how do I start this? I start this by remembering that it rains every day at the equator, meaning I have a low. And then on either side, remember, these are my subtropical highs. You guys, these are dry areas. These are where our big desert belts are, the Sahara, the Gobi deserts, etc. Okay, either side of that, I've got another low. Remember what lows mean. Lows mean rain and clouds. If you don't like rain, don't move to Seattle. There's the latitude of Seattle. All right, and then finally, the polar highs. And what's kind of always a surprise to students is the poles are kind of like deserts. They don't get very much. The definition of a desert is not hot. It's the lack of rainfall. And so you might say, well, it might rain, or not rain, but you might get 2 inches of precipitation a year at Antarctica, but it doesn't melt. It didn't until recently. It didn't melt, and so it was able to accumulate for many millions of years. All right, so I start with that. Now, the second thing I've got to always remember, we talked about this before, wind always blows from high to low. And then the third thing we have to remember, you guys remember the Coriolis effect. Okay, it's not a force. It only moves on things that are moving. It doesn't make them move. So it's an effect. And you have to remember that you're going to offset to the right in the northern hemisphere. Okay, offset to the right in the northern hemisphere. And you're going to offset to the left in the southern hemisphere. And I'm going to show you and walk you guys through this. Now, if you just remember those basic rules, you guys, I don't have this memorized, but as long as I can remember my basic rules. Now, there's a little problem here, is that we're going to make arrows, but we have to take the perspective of the arrow. We have to look down the shaft of the arrow. Now, I'm old. When I was younger, I could, mentally rotate things, and now I'm older, I can't. I actually have to physically rotate. So you'll see me flipping this, and you may not need to do it, but I do, and I think it might help some of you until you finally get it. All right, now I'm going to start here, and this is the southern hemisphere, you guys, so you have to know this. Come on. We live in the northern hemisphere. This is the southern hemisphere, and so remember that the rule is that we're going to offset to the left. All right, well, if we're going to offset to the left, I actually have to take the perspective of the arrow. And so we're going to blow from high to low. Remember the rule, high to low, and offset to the left. And look at this. I'm looking down the shaft of the arrow, and I hope you guys know your right from left. If not, you can write it on your hands. That's not considered cheating in my class. All right, so look at this. I'm blowing from high to low in the southern hemisphere, and I'm being offset to the left. Now, this is the example of where I would have to rotate this mentally for me, but I know my trade winds pretty well. Now, this is a right offset in the northern hemisphere. Let me show you. You gotta look down the shaft of the arrow, and notice that. That's an offset to the right. So check this out. Now, I'm able to mentally do that one just because I really know my trades. So what are these guys named? These are the northeast trade winds. You can just call them the trades, be friendly. And these are the southeasterly trade winds. These are really important. If you guys go traveling or you're sailors or anything, you got to know your winds. And in fact, the early explorers took advantage of these wind belts and boundaries to figure out how to get back and forth from the old world to the new world. Okay, so we also name winds from where they're coming, not where they're going. Okay, so that's why they're coming from the northeast and they're actually heading to the southwest. These are coming from the southeast and they're heading to the northwest. So those are my first ones. And again, look at the symmetry. All right, let's go up to the northern hemisphere again. I'm going to blow from high to low. That's all I have to look at. And I'm going to offset to the right. Okay, no mental rotation needed here. Okay, so look, I'm looking down the shaft of the arrow. I'm in the northern hemisphere. Okay, I do need to rotate here, you guys. Sorry, it does suck being old. Okay, moving that off to the left. Okay, so I'm in the southern hemisphere. I'm going from high to low, and I'm looking down the shaft of the arrow, and I'm rotating it to the left. So if you don't need that rotation, you can actually do it mentally. That's fine. All right, now what are these? These winds are called the westerlies. Now, if you want to get fancy, they're called the prevailing westerlies. But you know what? You can be friendly. Let's just call them the westerlies. All right, last but not least, let's do the one I don't have to mentally rotate. I've got to go from high to low. Now, you guys, the Coriolis effect is greatest between 60 degrees and 90 degrees north and south latitude. So really deflect these, deflect the heck out of them. So high to low, and give them a nice sharp turn to the left. Okay, see that? I'm really deflecting those guys. And I'm looking down the shaft and going to the left. Got to mentally rotate again, sorry. Okay, and I'm going to strongly deflect these to the right. So high to low, strongly deflected to the right because I'm in the northern hemisphere. So let me put this back and keep talking. All right, these are called the easterlies or the polar easterlies. I'll take either one, okay? Easterlies. And again, where are they coming from? They're coming from the east, easterlies. Now, you guys, this is symmetrical about the equator. And in fact, when I do this on an overhead, I can just kind of fold it up and check. But I can even do this here. They should match 100%, and they do, because they are symmetrical about. So they're kind of mirror images. I haven't ever gotten a mirror and tried it, but I should. All right, so those are my wind belts, and you do need to know those. Now, the last thing I want to tell you about are the wind boundaries. This right here has two names, the doldrums. Now, my parents are older, and so they use some funny words, and doldrums was a word that they used. And if you looked a little sad or thoughtful or something, they asked, are you in the doldrums? And that either meant, are you sad, are you thoughtful, or are you depressed? Now, it's called the doldrums. It's also called the Intertropical Convergence Zone. Okay, so you might see ITCZ. Doldrums is easier, you guys. And it's perfectly acceptable, too. So it's called the doldrums because the early sailors, if they got caught right here, remember what it does every day. It rains. If you get caught in this area, there's no wind. So you're going to be bored out of your head, out of your head, but you're not going to die because it's going to rain every day. You're going to collect the water and you're going to drink it. And so all you have to do is drift in the currents until you get into the wind, and then you sail off. All right, a little less happy are these latitudes, the wind boundary between the westerly and the trades, and they're called the horse latitudes. Okay, and remember, the doldrums are between the trades, and guess what? Symmetrical, you guys, horse latitudes. Now, why are they called this? This is a little sadder. The early explorers, the Portuguese and the Spanish, had their horses with them. They were, pretty much into their horses, and so they would go explore for the new world and they'd bring their horses. And this was good because if you guys think about wild mustangs are actually the escaped horses of these early people. And horses actually evolved many millions of years ago, starting like 50 million years ago in North America, but they actually went extinct in North America at the end of the last ice age. And it was actually the Europeans that reintroduced them. So something that's kind of cool. But let's get back to the sad story. What happens is that these early explorers, if you get caught here, remember, this is dry. And so they would either have to eat or they have to kill their horses, eat them or throw them overboard because horses drink a lot of water and they were dying of thirst if you got caught in here for too long. So that's why they're called the horse latitudes. Kind of sad. I love horses. All right. And finally, between the polar easterlies and the prevailing westerlies, we are going to have what's called the polar front. Okay. And again, down here, the polar front. And that is the boundaries between the westerlies and the easterlies. So you guys, make sure you download a few of these, print them out, practice. I promise you, if instead of complaining and worrying, spend 5 minutes, use my rules, and I bet you can come up with these. I'm not, I don't have these things memorized, but if you ask me to draw them, I'll draw them, and then I can discuss them intelligently by going from basic principles. And my basic principles are: it rains every day at the equator, therefore it's a low. Wind always blows from high to low. You offset to the right in the northern hemisphere, to the left in the southern hemisphere. And yeah, there's a few names to learn, but you guys, these are the winds that affect us. These are the winds that bring moisture onto Seattle. So that's why it kind of rains every day up in Seattle. And so, this sort of stuff is kind of important for you to know. Alrighty.